This is page 48 in your math journal. We're going to call this one terminating and repeating decimals. All right, when we have a terminating decimal, actually we're going to skip one line, we're going to write a couple of definitions first. So first definition is rational number. A rational number is any number that can be written as a fraction. So if a number can be written as a fraction, there are two types of decimal numbers that can be written as fractions. Okay, the first kind is a terminating decimal. So underneath here, we're going to put another little star. So terminating decimal. And a terminating decimal, the decimal places end. So terminating means to end. So the decimal portion ends. Okay, to terminate means to end. So from there, I'm betting you can guess what a repeating decimal would be. A repeating decimal, the decimal portion repeats a pattern. Repeats a specific pattern. So most of the numbers you're going to work with are going to be rational numbers. There are some what we call irrational, and they're decimal numbers that go on and on and on, but do not have a pattern to them. One of those numbers would be like pi, 3.14, and it keeps on going and going, but there's no pattern to it. Okay, we have already kind of talked about repeating decimals before. But repeating decimals will be written with a bar notation. So that an example would be like 3.42, and we draw a bar over that. That means that this repeats 3.42424242 forever and ever and ever. But we don't want to write that out, so we just write that over what repeats. Okay, fractions, terminating and repeating decimals, percents, and integers are all rational numbers. If you'll think about a whole number like 3, I can write that as 3.0. Notice I do not have to write a decimal on that one. It terminates, it ends, the decimal portion ends. Okay, something like this, it repeats. So we are going to practice writing fractions in their decimal form. Okay, so here I want big stars to write a fraction as a decimal. Divide the top by the bottom. Let's be more specific. The numerator, which is the top of the fraction, the numerator by the bottom, which is the denominator. by the denominator. Oh, I'm not going to fit it very well. Let's see if I can squeeze it. Denominator. Okay, that means this one goes inside the box. Up here I'm going to write inside. And this one goes outside the box. This is the divisor. Okay, let's try us a couple of examples here. So we're going to write each of these fractions as a decimal. So we're going to write 1/3 as a decimal. That means I'm going to put 1 inside the box and 3 outside the box. 1 divided by 3. So, how many times will 3 go into 1? 0 times. Minus 0 leaves me with 1. Because I want a decimal number, am I going to write 0 remainder 1? No. I'm going to add a decimal point, annex to 0, and keep going. How many times will 3 go into 10? 3 times. Minus 9 gives me 1. Annex another 0. Bring it down. How many times will 3 go into 10? 3 times. So 3 minus 9 gives me 1. Okay, as soon as you can see yourself repeating something you've done previously, you know that this is going to keep going on forever and ever and ever. So the answer to this, I'm going to keep getting 3, 3, 3, 3, 3, 3, 3. So 1/3 as a decimal number is 0.3 with a bar over the 3. So this would be a repeating decimal. Okay, let's do this one. How about 5/12? Okay, set up my problem. 5 goes inside the box. 12 is doing the dividing, so it's my divisor on the outside. How many times will 12 go into 5? 0 times. Put on a decimal. Minus 0, I still have 5. So I'm going to annex a 0 and keep going. How many times will 12 go into 50? 12, 24, 36, 48, 4 times. 4 times 12 is 48. That leaves me with 2. Annex another 0, bring it down. How many times will 12 go into 20? 1 time. Minus 12 gives me 8. Annex another 0. Now I have 80. How many times will 12 go into 80? 6 times. 6 times 12 is 72, so minus 72. That gives me 8. Annex another 0, bring it down. Oh, I have 80 again. So what do you think is going to happen? I'm going to end up minusing 72 again. And that's going to give me 8. So once again, it's repeating itself. So once I see it repeat itself, now it's not always going to repeat the same number. But if you can see a pattern of it repeating, notice here it starts repeating at the 6. So 5/12 is equal to 0.416. But the bar is only going to be over the 6 because that is what is repeating. Okay, we can even do it with negative numbers. So we're going to try -1/4. So -1/4. The only thing different here is when I'm done with my math, my answer is negative. So I'm going to take 1 and I'm going to divide it by 4. 4 goes into 1 how many times? 0 times. So minus 0 leaves me with 1. I'm going to put on a decimal and keep going. Annex is 0, bring it down. 4 will go into 10 2 times. 2 times 4 is 8. Subtract 8, I get 2. Annex is 0, bring it down. 4 goes into 20 how many times? 5. 4 times 5 is 20. 5 times 4 is 20, so I'm going to subtract 20 from 20, and I left with 0. Okay, because I'm left with 0 and I have no other numbers to work with, I'm done. This number does not repeat. It doesn't keep going forever and ever. This is a terminating decimal. However, my answer, because this was a negative, my answer needs to be negative. So 1/4 is equal to negative 0.25. So this is just the decimal form. This is the fraction form of the same number. We're talking about the same exact quantities here. Okay, sometimes you might have mixed numbers. So we're going to try one mixed number. Let's do 2 2/3. Let's do negative 2 2/3. Okay, before I do anything, I want to make this improper. So 2 times 3 is 6 plus 2 is 8. So this is equal to negative 8/3. So I'm going to put 8 in the box. 3 over here. And remember, my answer is going to be negative when I'm done because this original number was negative. 3 goes into 8 how many times? 2 times? Well, we knew that because we had 2 whole units here. Annex a decimal. 2 times 3 is 6. That leaves me with 2, so I'm going to annex a 0 and bring it down. 3 goes into 20 6 times. 6 times 3 is 18. Subtract 18 from 20, and I'm left with a 2. Annex another 0. Bring it down. Oh, 20 again. Well, that gives me a 6. 6 times 3 is 18. Minus 18 leaves me with 2, and I'm seeing that same pattern again. So, negative 2 2/3 as a decimal would be negative 2, and the 6 is going to keep repeating on forever and ever, so this is a repeating decimal. Okay, so terminating means the decimal ends. Repeating means that the decimal goes on forever in a pattern. And how do we write a fraction as a decimal? We divide the numerator by the denominator. Make sure this is written nicely in your notes.